From this video, we will start next chapter from physics, that is structure of atoms and nuclei. First, in this chapter, we are going to see different models suggested by different scientists about the structure of atom. The very first attempt to explain the structure of atom was made by J.J. Thomson. The model suggested by him is called Thomson's atomic model. Thomson's atomic model. What is this Thomson's atom model? The very first attempt to explain about the structure of atom was made by Thomson. He put forward a model about the structure of atom called Thomson's atom model. Today we have rejected this model. We have rejected this model. Then also we are going to see how is this model. Why? Because this was the first attempt to explain about the structure of atom. Thomson performed different experiments involving the emission of rays from the metals taken in discharge tube. Emission of different rays, different particles taken in a discharge tube. From that, he concluded that these particles are negatively charged particles. These particles are negatively charged particles. And he put forward about the structure of atom, a model about the structure of atom. How is this model according to Thomson? And where these electrons are present, which are negatively charged particles in this atom? See here. According to Thomson, atom, which is smallest particle of matter, it is nothing but positively charged sphere. It is spherical in shape, having positive charge. It is spherical in shape and having positive charge. According to him, the size of this atom, which is positively charged, is in the range of angstrom. According to him, this positive charge is distributed uniformly inside the sphere. This positive charge is distributed uniformly inside the sphere. Since there is a uniform distribution of positive charge inside the atom, according to him, no emission of this positive charge takes place from that atom. However, according to Thomson, negatively charged electrons are present inside the sphere. They are very small in number. They are very small in number. Though they are small in number, the charge on the electron is exactly equal to positive charge present on that sphere. Therefore, according to Thomson, this atom, which is in the form of sphere, is electrically neutral. Why? Because the charge on the electrons which are present inside the sphere is exactly equal to charge, positive charge distributed in that sphere. These negatively charged electrons, they are embedded inside the sphere like this, just like nuts in fruit cake. Means randomly, anywhere. They are embedded inside the sphere. This model is also called plum pudding model. Plum pudding model. With the help of this Thomson's atom model, or this Thomson's atom model can explain the formation of ions, ionization process. But this model is unable to explain hydrogen spectrum, which we are going to study in this chapter. Also, this model is unable to explain the scattering of alpha particles from thin metal foil. Due to this drawback, today we have rejected this model. Today we are not accepted this model. This model does not explain hydrogen spectrum. Also, this model is unable to explain the scattering of alpha particles from thin metal foil. Therefore, we have rejected this model. But it was the first attempt. Therefore, we have to study how is this model. Next attempt about the structure of atom was made by Rutherford. Before to see how is this Rutherford's model, there is one experiment called Geiger-Marsden experiment. I will explain this experiment in short, and then we will see what is Rutherford's atom model. First, I will explain here Geiger-Marsden experiment. Geiger-Marsden experiment, which is about the scattering of alpha particles. Rutherford suggested his model using this experiment. How is this experiment seen? Here, a radioactive substance is taken as the source of alpha particle. Suppose this is radioactive substance which emits alpha particle. You know that alpha particles are positively charged particles. They are equivalent to helium nuclei. Fine beam of this alpha particle is obtained. And this fine beam of alpha particle is made incident on some thin metal foil, generally gold foil. Metal, which metal is there? Gold. This beam of alpha particle is made incident on thin metal foil. Generally, gold foil is taken. What is observation here? scattering of alpha particle takes place from this. Scattering of alpha particle takes place from this metal foil. With the help of detector, which is movable on a circular scale, taken around this metal foil, we see that with the help of detector, this is detector, which detects the scattered alpha particles. We observe that here, most of the alpha particles from this beam, they go through this metal foil without any deviation. Nearly 99.9% alpha particle pass through that metal foil without any deviation. Means when detector is here, this detector detects large number of alpha particles, about 99.9%, which comes through that foil without any deviation. Some alpha particles, nearly 0.14%, 0.15% like this, 0.2%, they show deviation from their path through small angle, through very small angle. They show deviation from their original path through very small angle. While very few, out of 10,000 only one alpha particle, out of 8,000 only one alpha particle, this proportion, very few in number, they show deviation through an angle greater than 90 degree. Through an angle greater than 90 degree. Their number is very, very few. Most of the alpha particles go without any deviation through that metal foil. This is called Giger mass-gun experiment, which is about the scattering of alpha particles. Rutherford studied this experiment. And he put forward some postulates about the structure of atom. Called Rutherford's atomic model. What is this Rutherford's atomic model? See here. Rutherford's atomic model or Rutherford's atom model. How is this Rutherford's atom model? In this experiment that we have seen, Giger's mass-gun experiment, one observation is that almost all the alpha particles, nearly 99.9%, they pass through the metal foil without any deviation. Rutherford studied this. Only few particles show deviation through small angle, and very few in number show deviation through an angle greater than 90 degree. Rutherford studied this experiment. According to him, in the atom, there must be some massive particle which is positively charged. In the atom, there must be some massive particle which is positively charged, due to which the scattering of alpha particle is observed. And this particle should be very, very small in size. This particle should be very, very small in size. Why? Because in experiment we have seen that 99.9% alpha particles go without any deviation. Only few are get deflected through some angle. Rutherford suggested idea of nucleus. According to him, in the atom at center there must be a positively charged nucleus in which almost all the mass of that atom is concentrated. In center there must be a positively charged nucleus in which almost all the mass of that atom is concentrated. This central core, he gave the name for the central core as a nucleus. While negatively charged electron should revolve around this nucleus. Suppose this is atom. In center, according to the report, there is a positively charged nucleus in which almost all the mass is concentrated. Surrounding this nucleus, electrons should revolve in circular orbit, negatively charged electron. Surrounding this nucleus, negatively charged electrons should revolve in circular orbit. He assumes circular motion here. Otherwise, electron will get attracted towards this nucleus and will get fall in that nucleus. Therefore, according to him, electron should revolve in circular orbit around that nucleus. The number of electrons revolving around the nucleus, according to the report, is always such that the atom as a whole behaves electrically neutral. The number of electrons revolving around the nucleus is always such that the atom as a whole behaves electrically neutral. According to him, the size of atom is in the range 10 raised to the power minus 10 meter, while size of nucleus is in the range 10 raised to the power minus 15 meter. Means the size of nucleus is 10 raised to the power 5 times less than the size of atom. 10 raised to the power 5 times less than the size of atom. This is Rutherford's atom model. According to Rutherford, electron revolve around the nucleus in circular orbit. The required centripetal force for this. The required centripetal force for this is provided here by electrostatic force of attraction between nucleus and electron. Is provided by electrostatic force of attraction between nucleus and electron. According to the report, the maximum mass is concentrated inside the nucleus. Very few mass in the form of electron is revolving around that nucleus. Major portion of this atom is an empty space. Major portion of this atom is an empty space, and therefore in Geiger-Maserang experiment the observation is that 99.9% alpha particles pass through that metal foil without any deviation. According to Rutherford, this alpha particle should be passing through this empty space. Therefore, there will be no deviation in their path. Therefore, there will be no deviation in their path. Only that alpha particles will get scattered, which passes from this nucleus near to that nucleus. Suppose one alpha particle is coming like this and is going from near to this nucleus. That alpha particle will get scattered from original path. And these are very, very few in number. Also, one observation is that very, very, very few number alpha particles get scattered through an angle greater than 90 degrees. Rutherford explained this. According to Rutherford, only that alpha particle will get scattered through an angle greater than 90 degrees, which directly strikes with this nucleus of an atom. Which directly strikes with the nucleus of an atom. Alpha particles are also positively charged. Nucleus is also positively charged. Therefore, there is a repulsion here, and hence alpha particles get scattered through an angle greater than 90 degrees. This is Rutherford's atom model. Today, we are not rejected this model. Also, we are not accepted this model completely. Why? There are some drawbacks in this model. What are the drawbacks? See here. Some postulates of Rutherford's model we have accepted, not completely. What are the drawbacks of this model? First drawback. This model does not explain hydrogen spectrum. What is this hydrogen spectrum? See. We will see this in detail later. In short, I will explain here. According to hydrogen spectrum means, if we take a system of hydrogen atom and suppose that energy is given to the system of these hydrogen atoms after some time interval, just in picosecond, microsecond, in this time interval, we observe that energy radiations are emitted from these atoms. And from this energy radiation, we can obtain a spectrum called energy spectrum, hydrogen spectrum or energy spectrum, which cannot be explained using this Rutherford's atom model. Why it cannot be explained here? See. According to Maxwell's electromagnetic wave theory, which is also called classical wave theory, whenever charged particle is in accelerated motion, energy is emitted from that charged particle in the form of electromagnetic radiation. Energy is emitted. In this model, Rutherford does not explain anything about the emission of energy radiation from the revolving electron. revolving electron, they are accelerated charged particles. They are performing circular motion. Circular motion is accelerated motion. Means electrons are here accelerated charged particles. Therefore, if we apply here Maxwell's classical wave theory, then there must be the emission of energy radiation. There must be the emission of electromagnetic radiation from this revolving electron. This model does not explain anything about this. Also, according to classical wave theory, electromagnetic wave theory, if there is an emission of, continuous emission of energy radiation from this revolving electron, then the energy of an electron should go on decreasing here. Energy of revolving electron should go on decreasing, and finally this electron, by performing spiral path, should fall into the nucleus. Because when energy decreases, automatically what happens? Radius of orbit in which electron revolve decreases. And finally one stage will come that electron will fall inside that nucleus, making nucleus unstable. If we apply electromagnetic wave theory to this model, we get this result. Rutherford does not explain anything about this. Due to these two drawbacks, we have not accepted this Rutherford's model completely. We have accepted it partially. Next model about the structure of atom is Niels Bohr's hydrogen atom model. We will see this in next video.